So here's a graph up here. Typically the life cycle curve, every piece of equipment, whatever it may be, light bulbs, pumps, even walls, paint, has a life expectancy. So if I take a look at this, first time I start out the piece of equipment, you can have two things that happen. You have infancy failure, which means I bought a limit. So once I get the first 15 hours of break-in, the whole thing disintegrates. Why? It was a bad part or a bad piece of machinery at the factory. But say it doesn't. Okay, so for the first year, it's in excellent shape. It's like a brand new car. Everything works on this car, right? But over time, if you notice, it starts to drop. So in the first 75% of its life, okay, this particular component, piece of equipment, I'm going to have a 40% drop in quality. It's just wear and tear. I'm using this air handler. I'm exercising these breakers, right? Or emergency generator. It's just wear and tear. I can't prevent that. Even with great, excellent preventative maintenance practices, it's just wear and tear in the piece of equipment. But do you notice what happens here after the 75% life? Look at what happens here. I get a 40% drop, right? I go from fair to very poor condition. So I want to keep close track with my records, with my CMMS. I want to track that piece of equipment, okay? That's why most CMMS systems, and ask your tour guide again, if they have a CMMS, how long have you had it? If they say we've only had it 1 year, then it's like, well, what did you use before that? I don't remember. I doubt it, though. They'll probably tell you we've had it for at least 15 years. That means they got 15 years, right, on this trend of recording equipment. Performance, maintenance activities, deferred maintenance, okay? Because if you look at here, see what it says here? $1 for renovation. So that means I can shut down my air handler. I can refurbish it. It's routine maintenance, right? Upgrades, replacements, refurbishments, versus if I wait to the very end, and it's going to cost me $4 to $5 on average. So I go up 5 times. And look at what I'm doing. I'm only saving, what, maybe 3 or 4 years? So what's more cost advantageous? Set it on a routine refurbishment schedule. That's going to be the most cost advantage for your organization, right? I'll give you a real life example.
Is that the average of
typically? Yeah, typically.
75%
Mm-hmm.
of it.
So say it's a 30-year okay piece of equipment.
20 years you're going to start seeing it.
Yeah, or 23 or 24. Yeah, you're going to start to see degradation. But again, you record that predictive maintenance, your oil analysis, your infrared. So what you're doing is you're predicting what the failure rate of this piece of equipment. So what you want to do is time that. Okay, so now it's time to take this unit down, completely go through the entire thing, refurbish it, get it back online. And what am I going to do to this little line here? I'm going to extend it, am I? Right? So every year that I extended the life of that piece of equipment means I didn't have to replace it. I didn't have to have the cost for refurbishment, replacement, or capital costs. So, for that, I'm getting like 3 for 1, 4 for 1. Okay? I'll give you an example, real life example, because I did it. Air handler, large air handler at my facility. It's been in there since 1982. I replaced it in 2005. I had 2 choices going at my curve here. One, I could replace the entire unit for $1 million, or I could refurbish it for $200,000. What do you think I picked? I did the refurbishment. What? It's been $1 million, right? I had the unit assessed by a mechanical contractor, Comfort Air now, and they told me, Patrick, this unit's shot. And I said, looking at it, I need to replace the deck, metal plate, the coils. I know I had to replace the large refrigeration, water-cooled coils, and the hot water coils. I was going to replace the motors. I was going to go ahead and epoxy coat the interior. I was going to replace my filter racks and regasket and reseal them. $200,000, right? So I figured, shoot, I just saved the company $800,000, right? So I shut the unit down. I go in and I start taking things apart, right? So every time I peeled back a layer of steel within the bulkheads, what did I find?
More problems.
More rust,
Yeah.
right? So I says, well, looking at my budget, I says, I'm running into my contingency. Well, you know what? It's got to stop. I got to get good metal, right? So I peeled back another layer, more rust. I got down to the I-beams that sat on the concrete floor, and the I-beams were rusted. So that $200,000 job, what do you think it ran me? Almost $1 million. I was better off to replace the unit ahead of time,
Yeah, but
right?
hindsight is 20/20,
Right.
man.
So fast forward 4 years, I had another air handler refurbishment. What do you think I did?
New, a new one, and I hope.
You're right, because you're thinking.
Yeah.
Right off the bat, capital appropriations, well, now it's 1.1 million with inflation. 1.1 million. Patrick, we can't do it any cheaper. No, trust me. I know. No. And sure enough, you start cutting this unit up, because again, it was the middle of the building, remember? I got to take it out in pieces. Okay? Yeah, I think you saw it, right? So I got to take it out in pieces. But for me, I felt real comfortable, because as they were taking out the rusted pieces because of water and saturation, humidity, and years of use, it was a slam dunk. So lesson learned is learned by what your history is on these particular. So any air handler, anything to do that, refurbished is going to be tough unless you really know the piece of equipment. Pump, they're a little bit different. You can replace the pump because it's hard to rust the entire metal. Chillers, you can retube. Some cases, replace the compressors in other cases. Okay? Yep. But the object to this one here is, again, scheduling the refurbishment at the optimum time, which is lowest cost to extend that life. And then you continue that. You can continue that for 20 more years, depending on the wear and tear piece of equipment. Okay. All right? Okay. And O&M plans, okay, are established. Biggest reasons, desired results, okay, is articulated and understand. Desired result, overall, maximize the life of your piece of equipment and optimize its performance levels, right? Okay, some regulations are going to apply for environmental health and safety. Okay, training, roles and responsibilities are, and this is entire personnel for maintenance. Okay, data collection and software selection. Again, going back to the CMMS systems, right? Training is going to be required. Repetitive. We covered these, I think, the second class, right? Customer service, remember I said call the 1-800 number. So when you have your vendors there, you know, I like to know your text desk. Call them up. You know, if you get a dial tone, or you get to press the buttons and wait, you know, for the next available, you know, that's not going to work. I need them now, so I want a human voice in some ways. And then what type of technical support do they provide? Let us check into it and we'll call you back tomorrow. It's like, no, I can't wait till tomorrow. So again, that's more or less the type of quality of service that you're going to receive from that. Okay. And then here's some typical screenshots. On this particular one is a work order system. So basically what you're doing, this is a complete history. This is a checkup, maybe on yourself personally, but this is an entire checkup. Shop who was assigned to, phone numbers, who called it in, what type of equipment is it, what type of stores did you use. And this next screenshot is inventory system. So you can tie, say for instance, I'm using 4 belts and maybe 6 filters, right? That in turn goes into an asset inventory system so you can keep track of your inventory automatically. So it automatically orders belts for you, filters. So again, that takes part of what the headaches out and the uncertainties. So as I maintain, as I support, as I respond to repairs, my CMMS system is going to keep complete inventory of what parts I need. Getting back to what Trevor was talking about, having the right amount of parts. Okay.
I'm noticing there's no number in there for shelf days.
No, but in some cases, if I did have shelf dates, I'd probably have a lower inventory count in those particular ones. Okay. But again, this is just an example. In this case here, it was carpentry. It was tiles. Unit of measure per ceiling tile, 2x4 ceiling tile, right? And really what I want to do is look at my usage. How often am I replacing tiles? Because if I'm replacing tiles, thousands of tiles every month, I got to beg to ask, right? Why? Am I replacing tiles just at a whim? Or, yeah, right? Okay. And where are they at? Well, we got leaks all over the roof and we'll just replace them because they're all stained. But then I go back to the root cause, which is a leaky roof. Or maybe it's a condensate pipe that's leaking, or maybe it's a chill water line that's sweating. It's got bad insulation on it. Okay. And then again, implementing a CMMS. I believe on one of your slides you got the entire implementation wheel on it. So again, these are the basic steps in that particular one. So let's talk about predictive maintenance for a little bit. We talked about preventative maintenance. Routine, regular, right, scheduled intervals. Predictive maintenance is going to be a little bit different. These are going to be scheduled and maybe not as often. So requires equipment to be monitored in appropriate intervals to allow effective evaluation to determine appropriate maintenance action plan. So I'm going to look at predictive maintenance to not only validate that my maintenance program, okay, is, I'm going to say, is acceptable and support performance. But if I look at the next item, predictive maintenance is a type of planned maintenance that utilizes technology, we're going to cover some of those, which allows for forecasting of failures. So I can forecast just on the wear and tear of a failure in a piece of equipment. Okay? Monitoring and analysis in the condition of the piece of equipment. Okay? So the benefits would be identify and respond prior to breakdowns, minimizing breakdowns and unplanned failures. Okay? Order required parts and materials only when needed, so I keep my inventory stores down to a minimum so I don't have a lot of inventory costs, right? Stored goods. Schedule appropriate resources, especially if it's specialty. If it's a specialty vendor or specialty supplier. Okay. Eliminate unnecessary preventive maintenance tasks and avoid catastrophic failures and any related additional damage impact. So let's look at some typical techniques, okay? And this might be in your quiz, by the way, too. Typically, infrared, oil analysis, ultrasound, vibration, alignment tools, and meggers, okay? Assessing the condition of electric motors, okay? So vibration monitor, hey, what do you think of that one? You know what that is? Yeah, swamp cooler. You think it's the end of life?
I think it was dead a long time ago.
Yeah, I mean, I'm not getting much use out of that, right? It's a paperweight up on the roof, right? Okay. But vibration, baseline new equipment during the initial start. So, going back to the construction and project management folks in this class, part of your commissioning plan is probably going to be vibration testing. So once you fired up a new piece of equipment in this particular building, if it's an air handler, chiller, or a pump, you're going to run baselines. Now, you may not do it. You may have a third-party consulting commissioning agent do that. But as a project manager, I want to know that. Okay, because part of that first spin-up, that first start-up, they're going to run what baselines on that piece of equipment. Once they set that baseline, that's what they're going to measure 6 months, 1 year, 2 years from today. That's what it ran 24 months ago, and it's still spiking right about the same level. What's going to bring some concern is when you start to spike. That's going to tell you that, one, it's time for a teardown, okay, predictive maintenance, or there's something going wrong inside that particular piece of machinery. Maybe it's bearing races, or maybe it's the bearings itself. Okay, maybe it's a shaft. Maybe I got too much wear maybe on a sheave or a bushing. Okay, and that's what it's happening. Then the oil analysis is going to tell me even more. So now I take my oil analysis and it tells me that I'm producing a high levels of brass now, which now tells me that I'm having fatigue inside the machinery. So I look at my life cycle. Remember that slide? And I look at that life cycle and it says, you know, I need to schedule this for a teardown within the next 6 months. Because if I let it keep going at this rate, it's going to self-disintegrate, right? So again, I want to maximize the life of that, okay? And again, pinpoint probable causes. It could be a bad shaft alignment. Oh, it's not a big deal. We just got to realign the shafts and retension the belts. Then you test it again, and sure enough, it dropped back down. So again, that's the nice parts about vibration testing. I wish we had one here. I don't have one, okay? And again, identify unacceptable levels of vibration prior to causing permanent damage. Because once that shaft is bent or once it's permanently damaged, the only other alternative you have now is to tear the entire unit down and replace that entire shaft. And some of those shafts, I was telling you, the air handler, they're like 6 inches round of, you know, pure metal, and they're grooved. So to make one of those shafts, I have to go out to a specialty house. Typically, they're back east. Okay. So again, now my downtime for that air handler is going to be extensive unless I have a backup shaft. Okay. Infrared thermography is another addition, typically for electrical panels, what it's mostly commonly used for, but you can use it for roofs. You can use it for building envelopes to find hot and cool spots. Mechanical equipment, if you've got bearing races that are running too high. Okay. NASCAR uses infrared. When the cars are going around the racetrack, every pit crew is measuring the temperature in the car. Tires, brakes, motor, driver, and looking at what the fatigue is. You know, the outside tires usually heat up more than the inside tires as you go around the track. So they're using this technology to prolong, how long you got to go in and change tires. Because what? On NASCAR, time is money, isn't it? So if you can extend that pit by 2 more laps, but you can gain, 2 or 3 seconds on the leader, right? So again, but they're using all this technology, and it's even getting down to the point where it's racing and everything else associated to that. So again, you can identify leaky valves. If I got chill water valves, I can look at the different variations of temperatures inside of the insulation. So now I don't have to peel back the insulation, especially if it's jacketed. I can run my thermography lens or camera, right? I can find out where if I'm leaking or seeping water out of valves. So again, predictive maintenance tank levels. If I have restricted flow in certain valves or pipelines or lines within my facility, hot water lines included, right? Okay. Oil analysis, again, identify the lubrication condition, but also monitor the equipment wear. Once I get the first 2 or 3, examples or test results back, say for instance it's a condenser pump, I plug those into my CMMS and it tells me my entire makeup on what type of metals that are coming back through that oil and what level. I want to keep that baseline at that level. So if that's a 30-year pump and I'm using this amount of metal, it's going to last me for 30 years if we do the calculations far out. But then say the 5th year, I'm starting to get more brass, maybe I'm getting more aluminum. So that's telling me that something inside the pump is starting to degrade. Shoot, I'm not going to make 30 years, but if I shut it down now in refurbishment, I'll get 30 years out of that. Okay? Would be one, okay? And again, I can adjust my PM frequency. Say the OEM calls to replace the oil, right? Replace the oil every 2 years. But my oil analysis comes back and my oil is maybe at 98% used. So, I made to improve that or increase that to every year. Or I get my analysis back and says, you've only used 10% of that oil life. So I can now extend that expensive oil change by another 24 months. And that's the cost savings. But again, that's some of the benefits of predictive maintenance. Okay. Ultrasounds, I can detect by dB levels leaks in my compressed air. You don't hear it with the regular ear, right, human ear, but you can hear it with an ultrasound. I can also hear the packings on the valve if they're starting to break down or leak. Okay. Pneumatic systems, I can listen to those as well for my air conditioning systems if they're older systems and controls. Okay. Pumps, motors, okay. And again, using this technology to determine what is the wear and tear in a piece of equipment and what's its life expectancy. And what do I got to do in regards to maintenance intervals, primarily, so they don't become like that cooler? Okay. Yeah.
You tell that by comparing what was new from your baseline? It's all based on your baseline.
So as you run down that line,
I don't know what it sounds like, but
typically you're going to have a headset on. Okay, you're going to run an sensitive wand, ultrasound wand, and then what you're going to do is you're going to pick up the different frequencies. So as you walk down, say it's a compressed air line. So you walk down and it says, I know I got a leak at that gauge, and I'm going to have that because it's a pressure relief. So that's a given. So you walk down another 50 feet, and you stop, and you picked up a leak, and there's 2 valves up there, ball valves. And you look at your records that says, a year ago that wasn't leaking. So you make a notation on your tablet or your palm top or your device, need to have 2 valves on section such and such inspected. So you go down to the next one, next one, next one. So then 2 days later, the mechanics show up those 2 valves, and sure enough, the gasketing on them, dried out, and you start on to get seepage of air. Now, in some cases, some folks will say, well, what's the big deal about compressed air? It takes energy, right, and wear and tear on a compressor to keep replacing that seeping air. So what I'm doing is I'm limiting the life of that air compressor. The more leaks I get, the harder it works. And I can usually tell that by the amount of cycles that it's running. This unit cycles about every 5.5 minutes. 2 years later, it's cycling every 3 minutes. That's going to be a clue in itself, right? Okay. Hot water systems, you have makeup water and chill water close, and we'll cover those too. Cooling process water, you have makeup. So when you record the makeup, in maintenance you record everything. You record the amount of gallons of makeup water in a closed loop system. So say I'm making up a gallon a week. Well, that's just seepage, right? But say I'm making up 100 gallons a week.
you got a leak.
Yeah, I'm going to inspect every valve that I got, every trap valve, every relief valve, to see which valve or valves are leaking water, seeping water. Because what happened is the more water that I'm introducing, domestic water, into a closed loop, means I got to put more chemicals in it to compensate, so the costs go up. Okay, so that's why it's so important that data tracking for maintenance is so critical. Okay. Again, implementation, personnel is going to be very important. Got to be committed. Okay, and they got to be willing to do what it takes. Okay, identifying the equipment on what you want to implement as part of your predictive maintenance, the technologies we just reviewed. Establish a monitoring frequency. It's got to go on a regular interval. If it's every 6 months, every 6 months. If it's every year, you don't want to alternate. Well, we'll do 18 months because you're going to lose those baseline readings. Okay. Select instrumentation that's going to be conducive for what you want to do. Establish baselines, and then the alert levels. Once I get more than 5 gallons of makeup water, that's an alert. I got to turn that in. If I'm at 4, I'm going to keep close tabs on that. In fact, I may increase the monitoring frequency by a month. Okay. So again, data is critically important. Okay. You know what these are? Yeah. Condenser units on an air conditioning system.